Hey everybody, here's a potential solution, and I forgot to write the number down, of question 8.9.16 from the Collaborative Statistics textbook. It refers back to exercise 15, and it asks us to construct 3 confidence intervals for the Asian responses in the previous. If you remember problem 15, it asks, would you welcome a Caucasian, would you welcome a Latino, or would you welcome an African American into your family? And we have some responses from that. There were 254 Asians asked. Of them, 77% said they would welcome a Caucasian, 71% said they would welcome a Latino, and 66% said they would welcome an African American. Now, these are point estimates, right? These are the centers of the samples done. We know that we can't report those as the true parameters because there's a margin of error about that. Hence the need for a confidence interval. We have to actually slap a confidence interval on there. So the way to do that, in all honesty, if we're using in class, is to use 1 prop z int. If you're in your TIs, you go to the stat menu, you go to tests, and it's choice A in the TI 84, 83. If you're in a TI 92, it is under the stat menu F7 key for intervals, and I forget which one it is down there. If you're in a TI 86, send me an email, I'll send you the program that you need to install. Anyway, what you have to do first, there's 3 things the TI menu asks you to do. It asks you to input the number of successes, the sample size, and the confidence. Now for all of these, it's 95% confidence, and for all of these, it's a sample size of 254. As far as what X value, since 77% of the sample said yes to would welcome a white into their family, you have to do 77% times 254. The problem with that is, that's not a whole number. And that really isn't a problem, that's just the fact that they rounded off 77%. It's not exactly 77. So the value that came out, what you do is you round that, whatever you get, to the nearest whole number. It's the best you can do. So 77% of 254 is about 196, 71% of 254 is about 180, 66% of 254 is about 168. Good so far? All right. And then you just run 3 individual confidence intervals on those triplets of data, if you will, the X, the N, and the 95% confidence. And what I get is just above 72% to about 82% would welcome a white into their family. So that's centered on 77, as you can see. It looks like it's about plus or minus 5%. So you got a 5% margin of error up and down. For would welcome a Latino, it's from 65% to about 76%. And again, 71's right there in the middle, so you've got about a 5% margin of error on both sides of that. And last but not least, we'll welcome an African American. You've got 60% up to 72%. This is actually 71.9, but I'm rounding everything off to the nearest decimal. This is a little bit above 72, so technically speaking, these don't touch each other. But for sake of argument, we're getting into really, really mathematical arguments here. Right? I mean, we're making all kinds of assumptions about the data, and we're also assuming that that 77 and that 66 are one side or the other of what they actually are. But for argument's sake, let's just put this just to the left of this, because I think that's what the book is getting at. And we'll address that problem momentarily. So there are the graphs of our 3 confidence intervals. Part B asks us, even though the 3-point estimates are different, do any of the intervals overlap? Clearly, these 2 do. Clearly. Clearly these 2 do, and it's arguable whether or not these 2 do, although they're getting very close to not overlapping. C, for the intervals that do overlap in words, what does this imply about the significance of the differences in the true proportions? Well, if they overlap, if you're in my 244 class, I like to refer to the parameter that we're trying to estimate as a fish in that interval. In other words, the parameter of the proportion of Asians that would welcome a Caucasian into their family, we are 95%, it's between 72 and 82%. So 95% of the surveys done will trap the true parameter. So in our survey right now, there's that true parameter between these 2 endpoints. So the problem with it is we don't know exactly where. It could be here, it could be here, it could be here. Same thing with this blue one, which is would welcome a Latino. Could be here, could be here, could be here. Now, it might very well be that the percentage of those that will welcome Caucasian is much higher than the percentage of those that will welcome Latinos, in which case this is higher than this. But what if it's like this? Then the percentage that would welcome Latinos is actually higher than the percentage that will welcome Caucasians. What if they're equal? So you see, you can't tell what's going on with this sample. The results are inconclusive. Same argument holds for would welcome Latino versus would welcome African American. Now, that's part C. We'll come back to that too. Part D says, for the intervals that do not overlap, what does this imply? Okay, let's pretend for a moment that these actually don't perfectly overlap. They're getting darn close to not overlapping, which we'll come back to in my part E and F here in a second. Well, that means that even at the lowest end of our estimate for would welcome a Caucasian, that's still higher than the highest end of the interval for would welcome an African American, which means that there is definitely a significant increase in the percentage of those that will welcome Caucasian versus African American. Even at the lowest, this is higher than this at its highest, which means we can be confident in saying that a higher percentage of Asians would welcome a Caucasian into their family than an African American. That's what the conclusion can be drawn from that. Okay? Good. That's very neat and clean, isn't it? Here's a couple things to think about. Number one, we did 3 separate confidence intervals. And this is attacked, if you're in my 244 class, this is actually attacked in the E questions underneath these, underneath the book questions. Each of those confidence intervals is done at 95% confidence. So if you're thinking of that from a probability point of view, that means you've got a 95% chance over time, over doing multiple surveys, of catching the parameter you're looking for. So out of every 100, you're going to catch it 95% of the time. So loosely using that as a probability, you're going to catch with this interval the parameter 95% of the time. 95% of the time, 95% of the time. Well, the problem is you have 3 independent intervals drawn here, don't you? So your overall confidence has now gone down, because the chance of you actually being correct all 3 times is now 95% cubed, which is less than 95%. Okay? So, think about this. In order to get your overall test back to 95%, you're going to have to raise your confidence level to something that cubed equals 95%, which is going to have to be higher than 95%. So let's just suppose it's something like, I don't know, 98. You can figure out what that has to be. It's the cube root of 0.95. But if it's 98%, that means your intervals are going to have to get wider. And if your intervals get wider, that means these guys are inevitably going to overlap. Because remember, with bell curve, when you bump from 95 out to 98, you have to move a lot further to pick up that extra percentage than when you're close to the middle, where the curve is very high. So there's one thing to think about. Other thing to think about is the fact that, suppose this is all you've got, but then you get the opportunity to survey more people. Okay. So you can then survey, say, more than 254. I mean, maybe you survey 1,000, which is roughly 4 times. Well, if you survey roughly 4 times, you're going to shrink your margin of error in half. So your margin of error is not going to be 5%, it's going to be 2.5%. Well, if it shrinks down to 2.5%, these bad boys are all going to get cut in half. You're going to lose a quarter off of each end. And all of a sudden, you've got pretty clear significance from green to red, with one assumption. And what is that assumption? Can you think about what it is? The assumption is that if we actually do survey 1,000 people, that assumption is that this is still at 77%. It might not be. It probably will be close. But if we got an outlier, which would be one of those 0.05 significance errors, it wouldn't be close. Something else to think about. A third thing to think about that we'll address in, say, week 8 or 9 of the course is there is a way to test this all at once without doing 3 separate intervals and therefore sacrificing confidence. But we'll get into that later in the course.